Let's talk about the activity lifecycle. Activities in Android do not have what you might consider the traditional main function that gets invoked when the component is first instantiated. Rather, an Android activity will go through a series of state transitions in its lifetime, where each of those transitions results in the invocation of a specific callback function associated with that state. The state-to-state transitions for an activity can be impacted by the presence of other activities, as well as what else might be happening in the application's task or backstack. Understanding the life cycle of an activity is important if you want to build flexible, responsive, and resilient applications. We want to understand the life cycle to make sure that our users do not have a poor experience. So we want to make sure that things like crashes don't occur when the application is interrupted. We also want to be good citizens. We don't want to consume resources when we don't need them. We want to be able to know when information should be persisted and when it should be retrieved. And we want to make sure that we can be responsive when the operating system wants to perform operations in our application, oftentimes to the benefit of the user. We want to make sure that we don't crash, and we want to make sure that we don't lose information. Now, this is essentially the life cycle in Android. When an activity is first launched, its onCreate function is invoked. At this point, the activity is created. Immediately after, the activity's onStart function is invoked, and we say the activity is started. And then its onResume is invoked, and we can say at this point the activity is resumed, or more commonly, running. Basically, the onResume function is the last thing that gets invoked before the user is able to interact with the activity. So they can only interact with it when it is running. When it's running, we say it's in the foreground. Our activity can leave the foreground and or lose focus at different times due to different things. And when that happens, our activity again goes through various transitions and results in the invocation of specific callbacks. Essentially, if another component, another activity takes focus from our activity will be paused, and the onPause function will be invoked. If our activity is not visible, that is, not only has it lost focus, but it has been completely obscured by the presence of a second activity, then our activity's onStop function will be invoked. Now, whether our activity is paused or stopped, if it is brought back to the foreground, then we will have the appropriate function in the lifecycle be invoked. If we're coming back from a paused state, going to the foreground, our onResume will be reinvoked before our activity is considered running. If we're coming back from a stopped state, then first an onRestart function is triggered, then onStart, then onResume, and then the activity is running again. When stopped for an extended period of time, that is, if our application is in the background, Android may opt to kill our activity and all other components in our process in order to reclaim memory. Even if our application is killed, Android keeps a record of the fact that our application is running, or rather was running, and presents it to the user, allowing them to essentially restart the app by selecting it. When that happens, our activity goes back to its onCreated state, or its onCreated callback, followed by onStart, onResume, and then it is running. If our activity is running and we call finish, or it is destroyed by the user or by the system, unpause followed by unstop followed by undestroy will be invoked, and at that point the activity is shut down. Now, understanding this life cycle is important. So to do that, let's put this in the context of something that allows us to explain each of these states and their value. So imagine this activity was a game of some kind. Think of a very simple platform game where you're moving a character around on the screen. The game has music. The game allows you to move around and do different things. For simplicity, let's say that we are in the middle of the game. Let's not worry about how we got here just yet, but the game is actively running. If the user, say, hits a button that brings up a settings screen, so the user wants to change some aspect of the game, so they hit a little icon and a new window pops up above the main game interface. You can still see the game's interface in the background, but it's partially obscured. In that scenario, our game activity would be paused and its unpause would be invoked. If we think about it, what would we want to happen when that settings dialog pops up on the screen if the user was playing the game? Well, you can imagine that we would want to make sure that the game is paused, meaning we would want to stop all action on the screen. If there were enemies progressing towards the player, we would want to make sure that those enemies cannot progress. The user cannot move. Essentially, all actions have ceased. If that's the case, we would put all the code to get that result, pausing the progress of all characters in the game. That code would be placed within our unpause function. Now, notice here, all we've said is progress or movement in the game would be paused, would be stopped. But things like the music would keep playing, because while the user is messing around with the settings, you wouldn't necessarily expect there to be no audio coming from the game, coming from the main screen. That being said, if the user hits the home button or a phone call comes in that takes up the entire screen, now you can imagine what state you would want the game to be in. The user hasn't officially exited, but they can no longer see the game. Well, certainly we'd want to pause. We'd want to make sure that there is no forward progress or no entity is moving within the game. But what's more, we may also want the music to stop playing. Because at this point, if the user is not actively engaged with the application in some form, it would be peculiar to have the audio, well, perhaps not the sound effects, but the music from the game being played continuously. So we certainly want that to stop. So what we would do then is place the code to stop the music inside of our unstop function, because this is the callback that gets invoked when the activity is no longer visible. So if we don't want music to play when the activity is not visible, we put it in the unstop. So in unpause, we put the logic to make sure that all elements freeze. In unstop, we put the code to make sure the music stops playing. Conversely, if the game is paused because the settings screen is visible and then the user closes the settings screen, we want all movements to continue. We want the game to progress. So we will put the logic to have movement in the game, to have activity in the game inside the onResume function. So movement is paused in unpause and it resumes in onResume. If the music is stopped in unstop, then we would, and I'll talk about this one in a moment, but we would place the code to play our music in onStart. We stop the music in onStop. We continue the music in onStart. Now, if I'm playing the game and I decide to close it, I'm done playing, maybe I'll continue playing later or tomorrow, then exiting the game is first going to pause it. So that would stop all progress. Then onStop would be invoked. That would stop the music. And then onDestroy would be invoked. Well, what would we want to do before the game exits entirely? Well, we may want to save the user's progress. We want to know where they are, and we want to persist that to a file or something else. We may also want to clear up the memory. Maybe we want to unload our audio files or our image sprites, our image files, because they take up so much memory. So we want to clean things up. So we would put all of that in onDestroy. Make sure that there are no remnants of our application remaining when the activity is closed. If that's what we do in onDestroy, then we want to do the reverse of that in onCreate. So in onCreate, that's where we would load the music files. That's where we would load the image files. That's where we would load the user progress, if there is any, so that the user can continue playing from the last place they left off. So with that logic in mind, let's run through the activity lifecycle for the first time. So the activity loads. Well, what gets triggered? onCreate. Well, what logic did we have in onCreate? What code was written here? The code to load the sprites, to load the audio, and to load my progress, or zero progress if I had not played before. Then what happens in onStart? We start playing the music. Then what happens in onResume? I now start the activities. Whatever movement or actions the game allows, that's now enabled. And now the user is actively playing the game. What happens when they pause the game? All activity ceases, but music keeps playing. What happens when they hit the home button from playing to put the game in the background? All activity ceases and the music will stop. What happens when the user exits the game entirely? Activity is paused, music is stopped, progress is saved, and assets are unloaded from memory. Using that kind of mapping, we start to get an appreciation of how I can actually leverage the life cycle, that is, the various triggers of an activity, so that my application responds properly as the activity is transitioning from one state to another. All I need to do is override the correct callback and place my code there, specifying what I want to happen when the activity moves from one state to another state. Now here we see this onRestart function, and this is essentially just a differentiator. It allows us to know that the user is not just seeing start for the first time, but rather is coming back to onStart from a previous start. Now, it doesn't, just because we have the onRestart callback, it doesn't mean you must have a use for it. In fact, depending on the use case, you may simply ignore this. But we could also imagine that this might be useful to me in some way. For example, in our example, we said onStart plays the music. But maybe onStart, in the absence of any other information, will always start the music from the beginning. Well, in our code, we could then place in onRestart some code that sets the start position for the song to be some value other than 0. So the last location, the last timestamp of the song, that value, that flag or something is set by onRestart, allowing onStart to simply pick up wherever that flag is set. So essentially, I'm trying to inject onRestart into my flow, but you could also imagine that it might be possible to work around that and do everything on onStart. It really comes down to your use case. Is it important to differentiate a start from a restart? If the answer is no, you can ignore the onRestart callback. If the answer is yes, then you have this callback at your disposal to give you that differentiator between a fresh start and a restart. So let's take a look at this in action as best we can. We just want to see the invocation of our callbacks. So here I see my main activity. And if you'll recall, the logic is my main activity is able to launch second activity. Now, second activity being a full screen activity will obscure main activity when it's launched. In order to see the state transitions for main activity, we can simply override each of the main callbacks and print a little message so we know what's happening. So starting with onCreate, I'll simply log an indicator of the function firing. And then for each of the callbacks, I'll do the same. So after onCreate, it's onStart. Let's just copy this into our buffer so it'll be a little quicker for us next time. Then onResume. Then onPause. OnStop. OnDestroy. Now, with this logic, what we can do is simply pay attention to our logcat to see our messages printed. As our activity moves from one state to another, we'll be able to see that it moved from onCreated to onStart to onResume. As I click our launch, we see that when second activity loads, the onPause and onStop of main activity is triggered. When I close second activity, onStart and onResume is triggered. Now exiting will trigger my onPause, my onStop, and my onDestroy. Now, it's important to note here that more recent versions of Android will actually not call the onDestroy for your main activity when the user hits the back button. Instead, they'll put the activity in the background to allow for quicker loading if the user goes back to the application. But this is only the case for your main activity and only the case for relatively newer versions of Android. So for my second activity, for example, there would be no distinction. An onDestroy would in fact be fired in all cases. But if I was to target a more recent version of Android, this onDestroy call would not show up for my main activity. Again, we still have the rest of our transitions. This is just an optimization that Android introduced. Now, there are certain considerations that we have to have when we are thinking about our activity lifecycle. Essentially, what happens in our lifecycle can be impacted by a few different things. First, it depends on the task we're in, where in Android, a task is a collection of activities that are performing a single job. Now, a task here is not only activities from a single application, but rather activities from any collection of applications that are all doing the same thing. For example, if I wanted to take a picture in my application because I need to process that photograph in some way, then Android does not require that I have the code to take a picture in my application. Instead, I could trigger the camera application or a camera application that is already installed on the device to take the photo on my application's behalf and then pass the photograph over. In that scenario, when my activity launches the photo taking activity of a separate application, both of those activities will be in the same task. Most tasks are started from the home screen when the user first clicks on an icon to launch an application, but there are other ways that tasks can be started. When a task is started, it is given what's called a backstack, which is simply a data structure that allows the organizing of activities following the standard stack behavior, which is essentially last in, first out, or first in, last out. So you can imagine that as activities in a task are being launched, you essentially have one activity being placed on top of another activity. And when that top activity is either closed with the user hitting the back button or with us calling finish, the activity below it is placed on the top because our activity is essentially popped from the stack. So these things can impact our lifecycle. Lastly, every activity that is launched in Android has what's called a launch mode. Now, these can get pretty particular, and you don't need to dive into the nitty-gritty of all of them, but just know that they do in fact impact the way our activities behave. The two most common launch modes and that you are most likely to use are what we call the standard launch mode, which is the launch mode that you get by default if you don't do anything. And the standard launch mode essentially allows multiple instances of an activity to be launched. So you can have 10 different instances of an activity running at the same time, obviously with 9 at most, or at least 9 being in the background, but you can have 10 instances. Single top is a launch mode that says you can have multiple instances of an activity running at the same time, but you cannot have 2 instances on top of each other. There must be some interleaving or some separation across different tasks and different backstacks. So if you have an activity A, you cannot have another instance of activity A on top of it in the same stack. But you could have activity A followed by activity B followed by activity A if you are using the single top launch mode. Now, single task, single instance, and single instance per task apply really rigid restrictions on how activities can be created. Single task and single instance, as the names suggest, facilitate the creation of only a single instance of an activity, where single task allows for a single instance but allows that activity to be placed in a stack with other activities, whereas single instance says not only can there only be one instance of this, but it must be in its own task and its own stack. So you will never find other activities in the same task as an activity that is declared single instance. And lastly, single instance per task, there's a hint in the name. It's like single instance, except the rule only applies to a specific task. So you can have multiple instances as long as those instances are showing up across different tasks and different backstacks. One thing I'll simply point out here is that when it comes to the launch mode of an activity, it's important to understand that how you access the intent that was used to pass the message to you will differ depending on your launch mode. So an activity will have the intent that was used to launch it initially in the intent property, as you saw us do in second activity. So we were able to access the information that was passed to us using the intent that launched us by simply accessing the intent property. In the case where your activity is declared as single top, single task, single instance, then if a subsequent call is made to start your activity, but your launch mode or your activity state prevents a new instance of your activity from being created, then instead of the intent property being triggered or updated in any way, you will instead have a new callback invoked called onNewIntent, where the argument passed in is the intent that was used for this subsequent call to start activity. So you can see there are essentially multiple ways you can access the intent that was used to call you. Either the intent property, if this is the first time your activity is launching, or if your current state allows for new instances, or it may come through onNewIntent if your activity launch mode does not allow for new instances and you are already running. So with this in mind, we can understand how data can be passed from one component to another with a call to start activity using an intent.